Hey class, in today's lesson we're going to talk about combinations of functions, which is found in section 1.4 part 2. To find compositions of one function with another function, and we're going to use combinations of functions to model and solve real life problems. So in example 6, we're given that f of x is equal to x plus 2 and that g of x equals 4 minus x squared. And we're asked to evaluate f of g of x when x equals 0, 1, 2, and 3. So in order to do that, the first thing I want us to do is actually find f of g of x. So to find f of g of x, we are going to substitute g inside of f. So inside of the f function, I'm going to place or substitute my entire g function. So f of g of x will look like 4 minus x squared and then plus 2. Because it's all being combined just by addition, it's like I don't see the parentheses. And so 4 and 2 are like terms to give me 6. And so if I put it in standard form, this becomes negative x squared plus 6. All right, perfect. Now we will find f of g of 0, f of g of 1, f of g of 2, and f of g of 3. So to do that, all I do is substitute in our number into our function here. So that would be negative 0 squared plus 6. Obviously, 0 squared is just 0. There's no such thing as a negative 0, so the answer is just 6. On the next one, negative 1 squared plus 6. 1 squared is 1 times a negative 1 makes this negative 1 plus 6 makes this 5. On our next one, this is negative 2 squared plus 6. 2 squared is 4. With our negative, that makes this negative 4, then plus 6 makes this 2. And our last one is negative 3 squared plus 6. 3 squared is 9. With the negative, that makes it negative 9 plus 6, which makes this negative 3. All right, with try 6, we are going to find g of f of x this time. So this time we're putting the function f into g. So again, we're going to put the function f into g. So g of f of x equals 4 minus x plus 2 squared. All right, x plus 2 squared, I'm going to do that work out to the side. I'm going to use a box. You don't have to use a box. You could just use a distributive property, but this first one would be x squared, then 2x, and 4. On your diagonal, you have like terms. So this becomes x squared plus 4x plus 4. And that's within the parentheses. So this will be 4 minus x squared plus 4x plus 4. Don't forget to distribute the negative, and this becomes 4. I should move that over. This becomes 4 minus x squared minus 4x minus 4. All right, your whole numbers will cancel, and we'll be left with negative x squared minus 4x. All right. After we do that, we need to find g of f of 0, 1, and 2. So g of f of 0, g of f of 1, and g of f of 2. All right, if you put in 0, that'd be negative parentheses 0 squared minus 4 times 0. This will all just equal 0. On the next one, we'll have negative 1 squared minus 4 times 1. 1 squared is 1 times that negative makes that negative 1, and then minus 4, which makes this negative 5. And the last one, that's negative parentheses 2 squared minus 4 times 2. 2 squared is 4 times a negative, that makes it negative 4 minus 8, which makes this negative 12. Now I actually didn't see the last one. I'm also supposed to find g of f of 3. So we'll have negative parentheses 3 squared minus 4 times 3. Okay, that would be negative 9 and then minus 12. So that makes this negative 21. Let's keep going. All right, finding domain. So to determine the domain of a composite function f of g, you need to restrict the outputs of g so that they are in the domain of f. So for example, on example 7, it says to find the domain of the composition f of g of x for the functions below. So what we will do first is we will actually go ahead and put the function g into f. So I'm going to put this function here into f, okay? So that would be f of g of x equals the square root of 9 minus x squared, and that's squared, minus 9. All right, so a radical squared just becomes the radicand, so that becomes 9 minus x squared minus 9. And then if we combine like terms, we're left with just negative x squared. All right, so first of all, the domain of f of x, it is a parabola that has been shifted down 9. So the domain there is all real numbers, or it's like saying from negative infinity to positive infinity. Okay. However, the domain of g of x, if you looked at it on a graph, it's kind of like a semicircle. So it'd be from negative 3 to 3. So for us to have a domain of f of g of x, we will have to take the overlap of both. And so the overlap is from negative 3 to 3. And by the way, we could verify this in the calculator by putting in our original function of, like if I typed into the calculator, I could type in parentheses the square root of 9 minus x squared, that's a minus, sorry, squared minus 9. And our calculator would verify again that that piece right there is the only piece of our domain. Okay, let's try the next one. So it said to find the domain of example 6. So as a reminder, we had f of g of x. Sorry, I don't have it to refresh on the screen. But what it was 4 minus x squared and then plus 2. And that is because f of x was x plus 2 and g of x was 4 minus x squared. Okay, so to do f of g of x, remember, you put the g function into x. All right, so with that being said, let's go back. So the domain of, and this is terrible, this domain of f of x is a linear line. So that domain is all real numbers. And then the domain of g of x, it's simply a parabola that's been turned downward and has been shifted up 4 units, but it's also all real numbers. So the overlap of both would mean that the domain of f of g of x, that's an f, is also all real numbers, or I can say from negative infinity to infinity. All right, so example 8. So it says, given that f of x equals 2x plus 3 and g of x equals 1/2 x minus 3, find the following. So to find f of g of x, we need to put the g of x into f. All right, so here we go. F of g of x is going to equal 2 times 1/2 x minus 3 and then plus 3. All right. First, what we will have is that we can multiply this 2 and 1/2 which essentially will cancel out the 2 and the 1/2. So that will leave us with x minus 3 plus 3, and the x minus 3 plus 3 will just leave us with x. If I did the same thing on the other piece, however, so if I did the function f inside of g, essentially what I will have, so g of f of x equals 2 times 1/2 times x minus 3, and then plus 3. Again, the 2 and the 1/2 will cancel. I'm left with x minus 3 plus 3, and again, we get x. So what happens is these type of situations, you'll find out later what they really mean, but for now we're just practicing with the understanding that there are sometimes situations where if you compose into one another, your solution may be x, but we'll explain later what that means. All right, so decomposition. So to decompose a composite function, look for an inner and an outer function. All right, so you can actually, typically you can have multiple answers. So, but for now, we're just going to focus on the main one. So if we are to express the function below as a composition of two functions, h of x equals 1 over x minus 2 squared, what we're going to have, we need to find out what the f of x and the g of x could have been. Okay, an easy one that I see is I see that f of x could have been 1 over x squared, because I see a fraction, I have a 1, I have a divided by, and I said minus, I meant to say 1 divided by, and I see some expression squared, so that expression is going to stand for x. But in g of x, I'm actually going to write the expression as x minus 2. And then which one went into which? This one would be that h of x equals f of g of x, because I can easily tell that g of x had to go inside of f of x. So this is our answer. Okay, let's try this on the next one. Let's find an f of x and a g of x. So on the first one, I can say that my f of x is 1 over the square root of x, and that g of x is 3x plus 1. I also could have had 1 over x, and the other one have been square root of 3x plus 1. Same deal, okay? But again, h of x, in our case, will be f of g of x, just like it asked for at the top. On the next one, I'll have f of x equal to x cubed, and g of x will be the expression, which is 3x minus 5. So look for your inner and outer function. All right, some word problems. So the number of bacteria in a refrigerated food is n of t equals 20t squared minus 80t plus 500, where the domain t is from 2 to 14. It represents the temperature of food in degrees Celsius. When the food is removed from refrigeration, the temperature is T of t equals 4t plus 2, where the domain of t is 0, 3, represents the time in hours. Find the composite n of t. What does the function represent? So for us, it says find n of t. So we're going to put t of t inside of the n function. So we're going to put this t of t into the n function. So that will look like this. We will have 20 times 4t plus 2 squared, and then minus 80 times 4t plus 2, and then plus 500. All right, this 4t plus 2, you can go ahead and simplify that out. I've already done the work, but you can use this box to help you. But that would be 20 times 16t squared plus 16t plus 4, and then minus 320t, because now I'm distributing. 320t minus 160, and then plus 500. We still need to distribute that 20. So that will leave us with 320t squared plus 320t plus 80, and then minus 320t still, minus 160, and then plus 500. In the end, n of t will equal 320t squared plus 420. Okay, and then what does it represent? Well, n of t represents the number of bacteria as a function of the amount of time the food has been out of refrigeration. Okay, and that's it. In try number 10, it asks for us to find the number of bacteria in the food when t equals 2, and then find the time when the bacterial count reaches 2,000. So to find when the temperature is 2 hours, essentially that is n of t of 2. So according to our last function that we simplified for, that'd be 320 times 2 squared plus 420. Again, that came from the last problem that we simplified out. In the end, what we would have is 1,700 bacteria after 2 hours. Probably should have used my space a little bit more wisely, but here we go. The next one says find the time when the bacterial count reaches 2,000. So what that means is that n of t n of t is 2,000. So in other words, I'm setting it equal to 2,000. So in other words, 320 t squared plus 420 equals 2,000. I'm going to subtract 420. I'm left with 320 t squared equal to 1,580. If I divide by 320 on both sides, I'm left with t squared equal to, if I reduce that, 79 over 16, and then take the square root, and I get t equal to plus or minus the square root of 79 over 4, which is roughly 2.2 hours. And to be honest, guys, we really, technically, we don't have a plus or minus. We only have a plus because time can only be represented in positive numbers. Okay, that is it for today. If you have any questions, please be sure to stop by and see me for tutoring.